I'm from Federal Education Center for Technological of Minas Gerais in Belo Horizonte, Brazil. My talk is about the antiferromagnetic and ferromagnetic spintronics, the spin transport in the two-dimensional ferromagnet, and the role of in-chain-to-chain interaction. Uh, the outline of my presentation, I will talk about the interaction between electron with the ferromagnet domain wall, the local broken symmetry and spin supercurrent. I will talk about the two-dimensional ferromagnet with in-chain-to-chain interaction, the effect of in-chain-to-chain coupling on spin conductivity, and the last I will make my conclusions and final remarks. The interaction between electrons with the ferromagnet domain. Well, I have a schematic view of interaction among electrons with the spins of the ferromagnetic domain. While of with delta x is the phase angle among electron spin with the spin of the ferromagnetic wall. I have this behavior for the potential of the interaction between the electron with the ferromagnetic domain wall. I obtain this behavior for the contribution of the interaction between electrons with the domain wall for the electroconductivity given by a large peak on this range of the frequency. Consequently, I obtain a large contribution on the interaction between electrons with the domain wall for the electrocurrent. In the following, I study the local broken symmetry in spin supercurrent. I define the spin current given by this equation. I have the condition inside the superconductor in the same way that in the electric superconductor, I will have the gradient of external magnetic field is equal to 0. I have the wave function given by this equation. I can expand the modulus around the minimums of the potential given by this expansion. I obtain the Lagrangian given by this equation. For minimization of Lagrangian, I obtain the Procas equation. And I have the corresponding massive Klein-Gord equation given by this partial differential equation. I have the solution, this equation. I have the gradient of external magnetic field. I have a dependency of the exponential increase of x. I have the extinction of the gradient of the magnetic field in the penetration length of delta. The another problem that I study, I have studied the spin transport on the two-dimensional ferromagnet with in-chain-to-chain interaction. The models defined by this Hamiltonian. I have the three additional terms in the Heisenberg model representing the in-chain-to-chain coupling. I use the Schwinger boson formalism to study the spin transport of this model. This formalism starts defining the basis given by this equation. I define three boson operators acting in the vacuum state given by this equation. In following, I define the spin operator in terms, I make the transformation of the spin operator in terms of the Schrödinger boson given by this equation. After that, using this formulas, I obtained this behavior for the spin conductivity, where I have a large peak for the spin conductivity for in this range of this frequency. I obtained this behavior for some values of in-chain couplings. I obtained this behavior for the spin conductivity with the next nearest neighbors interaction given by this behavior. I obtained this behavior for the spin conductivity with interchain coupling given by this behavior. As a conclusion, in final remarks, I obtain a large variation of the spin conductivity with the frustration parameters of in-chain interchain interactions. My purpose is to analyze the effect of phase transition continuum conductivity, and the peak of the spin conductivity obtained can be determined by measuring of magnetization current. Thank you very much, but by attention.